Hi, this is Mrs. Slater. Question, why did the kids eat their homework? Think about that one while we talk about writing equations and from 1.6. Before you start a word problem, there's certain things to go through in your mind. Phase 1 is to make sure you understand the problem. Read through it a couple times if you have to, but that is very, very important. Understand the problem. What are you trying to find? What data are they giving you? Have you seen a similar problem that you can refer to? The next one is develop and carry out the plan. So this is where your equation is going to come in, and you're going to write down what you think the equations would be, the strategies to use, and how to carry out those strategies. And then phase 3, you want to find an answer, and then always check to make sure it makes sense. Okay, check your solutions, find out if they're reasonable, and then state the answer clearly with labels. And I'll show you what that means in the first problem. So what I want you to do is go ahead and open your book to page 33. If you left your book at school for some reason, I will read the problem and then I also will write it up. I'll pause it and then write it up. So don't worry if you don't have your book. But if you do have it, it'll be nice to have to look at. So, page 33, number 1. So this is what problem 1 says. You do not have to copy it down. As long as you have this reference number up here on where you can go back to in the future to study, that's what you're going to need and to have your book. Okay, so anyway, on this one, what data are they giving us? Because again, we have to understand the problem and what we're trying to find. It says that it charges $8.50 per job, and then also $6.75 per hour. So that's a lot of the information we need. So if it's a 7-hour babysitting job, the things you need to think about is now how to develop and carry out this plan. So 7 hours, okay, so you get a job. So we know we're going to have to use that at least the one time because this is a one-time job. Then this one right here, per hour matches with this 7 hours. So we're going to have to multiply that by 7 to figure out the total hours. So the equation, what it's going to look like is we have $8.50 plus 6.75 times 7, and then that's going to give you your final cost of the job. So if you go ahead and get your push pause, get your calculators out, and then go ahead and find out what that is. And hopefully you have $55.75. Okay? Go on to the next one, which is number 4. So the problem reads, a phone company charges 40 cents per long distance call. So that's the first piece of data that I want to write down. 40 cents per call. Okay, and then also plus 20 cents per minute. 20 cents per minute. Whoops, I don't need to write the word per on either one of them. So that's call, and then this is per minute. Okay, and then it says find the cost of an 18-minute phone call. So this is very similar to the last one, based on the fact that you have an 18-minute call, so that's an automatic one-time charge just for making the call. And then the minutes will be used with this 18 minutes. So there's 18 of them, so we're going to have to multiply by 18 to get the total amount. Okay, so push pause and see if you can get the equation. Okay, so hopefully it looks something like this. 40 cents plus 20 cents times 18. And when you multiply that together, there's going to be a little bit of, it may not make much sense. Now the reason that is because cents, we know in money, we can put that as a decimal. So there'd be a point, decimal point in front of the 4 and a decimal point in front of the 2, which now when you multiply it together and get the answer of $4, it makes more sense. Okay, always check to make sure it makes sense, that the answer is reasonable. For that one call, it would be $40. Okay, moving on to number 7. Okay, this one reads, the height of the Statue of Liberty is 93 meters. This is about .27 the height of the Hancock Building in Chicago. What is the approximate height of the Hancock Building? Okay, so I brought two pictures up. Now the way I have them pictured, it almost looks like they're exactly the same size, okay? So if you're away out of the country and you've never heard of the Hancock Building, don't know anything about that building, and you don't know anything about the Statue of Liberty, maybe this problem could be a little confusing. Okay, so we've got to really dive into what this problem means. Again, we got to understand the problem. So we all know that the Statue of Liberty is smaller than Hancock. But if you want to really look into what this means, maybe think this is about half the size of the Hancock Building, and that will help you know, again, if you don't know anything about them, to know that this would be smaller than Hancock Building. And I believe they're talking about just the base being 93 from here to the torch, 93 meters. And that's what we're going to look up. So we need to know how to set this up in the equation. So let's start off with this. It reads that the Statue of Liberty, so I'm going to go ahead and abbreviate there. And then it says is, that is the key word. We talked about that last week. Is means equal to. So as the sentence says, the height is 93 meters. So we have Statue of Liberty is 93 meters. That is what the first two things say. So we've got is in this one, and now we have the new one, and this is, so they're saying this Statue of Liberty is 0.27 of the height of the Hancock Building. Okay, this is 0.27, so the Statue of Liberty is 0.27. Okay, so once we know that, now we have our new variable. I'm going to go ahead and get rid of the meters because that's not a significant part of this particular problem. So I'm going to label this with an H. That's going to be the height for the Hancock Building. And once I divide both sides by 0.27, I get an answer of 344. Now we can bring the meters back in. So it makes sense. The Hancock Building would be 344 meters is the height of Hancock Building. Okay? All right, let's try number 8. Okay, so this one says the area of the Red Sea is about 18% of the area of the Mediterranean Sea. The area of the Red Sea is about 453,000 kilometers. Find the approximate area, and area would be squared, so I'm missing a little squared sign. Okay, so let's understand the problem. It is 18%, so whenever we're dealing with equations, we've got to make sure we transfer that into decimal. Okay, so that's the first thing we need to know. And the next part would be reading what it says. We got the Red Sea, so I'm going to abbreviate that RS, is, there's our equal sign, about 18%, 0.18 of the Mediterranean Sea. Okay, so that's how you can set it up and try to understand the problem. And this will also help you develop and carry out the plan as well. Okay, then the next sentence, the area of the Red Sea is 453,000. So Red Sea, that was my abbreviation for Red Sea. I'm just going to replace in that information, and we've got the Mediterranean Sea there as well. So go ahead and get out your calculator and divide both sides by the 0.18. And so the Mediterranean Sea area is what? All right, so hopefully you got the answer of 2,516,667. And we know that this is an approximation, so there's the symbol for approximately. Okay, so now go out of the book just a little bit and work with percent population growth and increase. So our answer is going to be in percent. And the formula to think about for any kind of population, if it's a population of how many students are entering our class and leaving our class, that's one thing, or a population of Lake Forest or Lake Bluff, those are all things that, that use this formula. So you have the new population, the actual number, minus the old population. I'm going to start abbreviating that. And then if you divide by the old population or the previous one, then that's going to give you the percent of population growth. Okay, so let's go ahead and use this formula. Okay, so we have 26 students in our class. And let's say that 5 students found how cool this class was and wanted to get in here so bad. So we want to add 5 students. So the question is, what is the percent of population growth? Okay, so how we would set this up, since the new population would be added on to the 5 would be a total of 31. And then if you subtract the old, we had 26 students, we're going to divide by the old to get our percent. Okay, so you always want to clean up the top first. Obviously that's going to be our 5 students that we just added. And when you divide it by 26, you're going to get 0.1923. Okay, so we want a percent. So we'll have to move our decimal place over 2 places. So it's approximately 19% population increase. All right, very good. So the next one's kind of tricky because you would think that if those another 5 students left the class, it would be the exact same percent, but that is not the case. So let's have the room is so crowded that our 31 students that we have in this classroom, 5 of them want to leave because it is too crowded and there's no room to do any kind of math in here. Okay, so what is the new population? So if those 5 students leave, it's going to be 26. Okay, and then 26 minus the old population of 31 divided by the old population. This will give you a number. Go ahead and clean up the top first and see what you get. Okay, so hopefully you're getting -5 on the top with 31, and then -0.1612. Again, this is approximately. Okay, so the negative represents, because it is a population decrease, there's less students. So decrease is the negative. Okay, and then we want to change this into percentage. So it would be 16% population decrease for this one. Okay, and they are not going to be equal to each other. If you put 5 in a classroom for its population and take 5 out the next day, the percent is not going to be the same. So you will see this relating to a lot of the questions that you see on tests and quizzes and then in your assignment tomorrow. Okay, so I will end with the answer to the joke. Why did the kids eat their homework? Because the teacher said it was a piece of cake. So I hope you have the same situation tomorrow.